Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 2 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California, and Jeff has some cyber security news for you to kick us off.
Okay. If you could.
You sharing?
Yeah, share screen.
Okay.
Okay. Well, CloudStrike, we finally found out what it was. What caused it.
Is it CloudStrike or CrowdStrike?
Sorry, CrowdStrike.
Or ClownStrike?
Yeah, CloudStrike, but CrowdStrike. I keep saying CloudStrike because there's Cloudflare.
Ah, yes.
Which is actually a decent company.
Right.
CrowdStrike, well, okay. Found out what it was, and
you found out what's happening?
What happened?
Okay.
What caused it?
All right.
And they link to here, which is nothing but it links to this PDF that is a 12-page PDF of what happened. But essentially, what happened, and if you're a programmer, you'll get this better than. Oh, hi, Janie.
Happy Olympics Friday to you too, Jamie.
So, if you're a programmer, you'll get this. The old version. Oh, you can show both.
Oh, okay.
The old version of this one routine looked for 20 parameters. Basically, you passed it 20 different things. The new version added a 21st parameter. So it's expecting 21 parameters. However, none of the other programs in there were modified to give it 21 parameters.
So is this sort of a checksum thing or something else?
Well, sort of. But here's the thing, is that within it, when it tried to use that 21st parameter, it pointed to nothing.
So it didn't like that.
So it's kind of like a divide by zero type of thing. Oh, hey, Scott.
Hey, Scott. Hello, everyone. I saw last night's video with David and thought that I had missed it live until I saw the description. Yes, that was one of our very first guests. David was on, gosh, almost 4 years ago now, I think. Thanks for watching that, though. He definitely deserves to be up in the ranks of our playlist of guests because on Facebook he had 254 views, and then there's some more from, anyway.
Right.
Okay, I'm sorry, Jeff. Go ahead.
Yeah, but we weren't doing YouTube at the time, so.
No, we weren't doing YouTube, so.
Yeah.
Yeah.
So, so because it was looking for, because it tried to use that 21st parameter.
Yeah. Computers are persnickety that way.
Yeah. And here's the
Someone
other
would be
thing.
like, I don't think that's right.
Since this is endpoint security, it's supposed to secure Windows. So it loads as one of the very first thing that Windows loads, even before Windows operating system loads.
Okay.
Which means that when this program goes belly up, I wasn't going to use that phrase, but when this program goes belly up, there's no Windows for it to fall back on. And so basically it just throws an error out there, and Windows takes its next step of trying to load Windows and says, whoops, there's an error. Blue screen,
Do they actually know what the error was? Because a lot of times it'll come up with an error number like, 404.
Right.
That means not found. There's 405. There's all kinds of them. I'm sure
did have an error message. However, these error messages are only useful for things that have happened before.
Ah, okay.
Because they write them once they figure out what they need to write them for.
Oh, interesting. So now it's got an error number, right?
Yeah, probably.
Okay.
However, ClownStrike says that they've modified their test. Now here's the thing, is that they ran it against testing routines that stuffed a wildcard into that 21st parameter. So none of their testing routines noticed that there was missing data that would cause a problem.
That actually doesn't seem that strange to throw in a wild card, but.
Right, except that,
I don't know programming that well.
Except that the rest of the programs didn't do that. they didn't send that wild card.
I see.
And so
So they didn't catch it in testing because it was different than
right, they didn't catch it in testing.
real life.
Yeah.
Yeah.
You passed through testing. What that tells me, they don't state it in this article, and they probably won't ever, is that they did no live testing of it.
Oh God.
That's what that tells me. Because if they had run it the first
At
time
least
they
somewhere.
ran it, the first time they ran it on a actual Windows machine,
Yep.
it'd go kablooey.
Okay.
So they did not live test this before they pushed it out.
Even McDonald's tests things in certain markets before
Yeah.
it goes to the whole world.
Yeah. So
I used to work at McDonald's.
now they claim that they've changed things in their testing routines. No, they did not say that they're doing live testing. They've just changed the parameters in their testing routines so that this can never happen again.
Right.
Until something else very similar to it happens.
Got it. Okay.
So
anything else we should know?
No, just I wanted to let people know about that, because that is, since CloudStrike took out a whole bunch of stuff, yes. All of the airlines, almost all of the airlines except for Southwest, because Southwest uses Windows 3.1 computers. Yay for cheapness. Of course, now everyone knows just how to hack Southwest Airlines, because
they'll upgrade then.
Because even I can hack Windows 3.1, and I'm not a hacker.
Got it. Okay.
So that's all.
Okay.
That's all on that.
All right. So tonight's episode, we're gonna do a space news roundup. We'll be back in 8.3 seconds. Now, there are plenty of news sources out there, and this isn't our usual fare. But in fact, the last space news episode we did was 6 months ago. We do think it's important to have some awareness of space news. And we know that you're really, really good at, sharing with us the things that are going on in the world. And we really appreciate that. So please, if you have something that we haven't talked about, go ahead and mention it. So Jeff is taking point on this conversation. Go right ahead. Jeff, tell us some interesting spacer news.
Okay.
Am I sharing?
Yeah, do the split screen. Sure. Oh.
I was going to say, it looks like you're still on the old.
Yeah. Oh, I am. So thanks for the update. So sad, mediocre mess is so easy to create, huh? Yeah, because remember, this is the same one that was the chief information officer of McAfee when McAfee did the same thing. Yeah. So no conspiracy here, just he didn't learn. That's what that was. Oh, Jacqueline.
Oh, that's Cliff.
Oh, Cliff. Hey, Cliff.
Yeah.
Hey, Cliff. Your hair got blonder.
Oh yeah, we did a show with Dave, like almost at the very beginning. Like I was still on Facebook, and I did a few episodes of my own. It was kind of in its formation, and then we came over to StreamYard. I actually have broadcasting to 3 places now, so I upgraded my so now we're going to 2 places on Facebook and YouTube. So yeah, but Dave pointed out to me that he wasn't actually on the playlist for the guests. In fact, I still have at least one more guest to bring over and add to the playlist. So watch for that.
Yeah, because
Christine was one.
Oh yeah.
I think Christine was our very first guest, and total noob, but she had a really interesting thing to say about where she works.
Yeah. And
very cool stuff.
Yeah.
Okay. Yeah, I know. It came up last night because I finally downloaded it from Facebook and then uploaded it to my Everyday Spacer YouTube channel, and then added it to the playlist. Excuse me. And I also mentioned on Facebook that I had done that and tagged Dave so he would know, and he would get a chance to see that it was up.
Yep.
So
yeah.
Yeah.
And,
all right, are you ready? Oh
yeah. And space news isn't really it doesn't provide stuff for how to get involved in space, except that this is one of the ways that I keep involved in space.
Yeah.
So this is one of my activities, is that I have a number of sources that just basically feed me headlines.
And I think it's
And
great. So
And
yeah,
I rack them up. And
if you like the kind of thing and you like to stay up with it, and we know that a lot of people here have mentioned various things over the years, and I didn't have a timeline. Oh, I thought I mentioned something in the. You're talking about Dave's episode, right?
yeah,
I thought I mentioned something about because the picture for it is from the Facebook page, and I
right,
think it's got the date from when it went live
right.
on the air on Facebook. Oh, Jamie says missed it. Having tech issues extraordinary. Got locked out of Facebook. Unable to get back in. Oh no. Yeah, I hear.
Yep.
that kind of
Well,
thing
we're
for people.
moving the few things that were on that were Facebook only onto the YouTube channel, so that'll be
Yeah,
good.
I'll definitely get the guest ones up first, and then eventually I'll figure out which ones. Well, the demonstration is over here already. So,
Yep.
Are you ready?
Yep.
All right. Thanks for your patience, folks. Here we go with Jeff. He's going to talk about space in the news,
or just science in the news, because it's this is kind of space news. ISS has found a number of anti-helium particles, and I actually saw this. Oh, what Scott have to say?
It made me laugh because it wasn't. Yeah, I admitted that last night's video had me thinking it was Friday for a while. Nope, it wasn't. I was just catching up on a very old one of our first guests.
Then you need to drop these on Thursdays just to mess with people.
It's just mean. I'm gonna randomize it.
Okay. So they found anti-helium, which is basically two antiprotons.
I think we heard about that from
anti-helium.
Anton, right?
Yeah. Now I found this article before Anton talked about it.
Right, okay.
But he actually talked about something before we put it on the show instead of after we put it on the show.
I don't think he knows anything about us.
No, I know. It just he's stealing from us.
Yeah, no.
I know.
I don't think so.
But okay.
It'd be cool to believe that, though.
Yeah. Anton did a whole episode on this, so I'm just like a lot of these. I'm just going to touch on them and give this as something for you to, if it interests you, hey, this is something to look into.
I thought it was very interesting. And if you're here for the first time, we're talking about Anton Petrov. He does
a YouTube channel
almost every day. He does something on YouTube, and it's very, very news oriented, updates on science. In fact, he'll go visiting something he's done before, and here's the new thing about that. He'll say it's really, really a stellar channel on YouTube.
And he'll look at clickbait things, and if it sparks an interest in him, he'll do it and then say, yeah, no, probably not. He'll actually give his opinions as a scientist on them. Okay, so
he's a mathematician.
You're a mathematician, yeah. So helium, anti-helium. What's interesting about that? Well, they don't think it would survive long enough to have been created in the Big Bang, which is theoretically where antimatter would have been created, because matter, antimatter basically were created at the same time, boom, and then we're gone. So, but scientists don't think it would last long enough. Therefore, it had to be made, or theoretically, it had to be made after the Big Bang.
So
what made it?
New-ish.
And they're suggesting cosmic fireballs made from dense dark matter collisions.
Right. Yeah.
And Anton talked about that. So interesting. This could lead to something else in science. If nothing else, antimatter atoms and molecules behave just like regular matter molecules and atoms. Just if they make contact with normal matter,
they annihilate it.
Yeah.
They annihilate each other, I think.
Right.
Yeah.
So.
And as he was talking, where's all the antimatter? That's part of the problem is where is it? I'm like, it's probably in an alternate universe.
Yeah. Well, yeah, and
it doesn't have much matter.
That's the thing. Theoretically, matter and antimatter were created equally.
Yeah. Oh, yeah. Cliff says Anton is great. Just don't talk too quick to understand him sometimes.
Yep.
Yeah. He's not too bad.
He has a little bit of an accent, but it's not bad. Now that might, for those who don't spend a lot of time talking to people with various accents, it might be a problem, but I don't think so.
I didn't think so.
Yeah.
And I think he's from Canada, but he lives in Korea, something.
Yeah,
something
South
like
Korea,
that. Which
yeah.
I don't quite understand where that accent comes from Canada, but
Well, it's French Canadian, possibly.
it could be. Yeah, could be. Yeah, some places in Canada are very, very French.
Yes.
They insist on French speaking.
Yeah. All of Canada is by law bilingual, except for Quebec, where they only speak French.
Yeah.
Okay, so a unique transistor. I'm a computer guy, so this interested me.
Yeah, I can't wait to hear more about this one.
Yeah, this one can switch between positive and negative in nanoseconds and can withstand over 100 billion cycles without wearing down. Because
something about telling too in this one, right?
There's a couple of different things. I have a couple of articles on these.
Okay.
But yeah. So here we go. Oh, that was interesting, but that's an unrelated video. So what it is two plates of material slide like this. Oh. So it's a physical move.
Okay. So I can see how that could be switched between them.
But it's like two molecules moving against each other.
Okay.
And so it's kind of like they're on magnetic buffer, so they don't actually make contact. And the number of, and just one way is they choose as a 1 and the other way as a 0.
Okay.
And it can change really fast. And
this is kind of on the heels of watching the video that Cliff shared from 1967 about how they
make silicon wafers.
Yeah, how they make the wafers. And I didn't know it was a glass. What do they call it? A glass something? It was a really cool video.
Well,
so
that's how they used to do it.
Yeah, that's how. Okay.
Yeah. Nowadays,
so
they can't actually print something small enough to use it as a mask.
No.
Oh. Yeah,
Cliff has a comment. Yes, excellent, but a bit hard for some of the older people in my live club in Pomona. Okay. Got it. Yeah, I would just replay it.
Yeah.
And you can actually, if it's a YouTube video, you can slow it down a bit. You click on the gear and you pick a different playback rate.
Yeah.
And they do like regular 1.5, 1.25, or the other way. So it's faster or slower. Yeah. You could go either one.
Yeah. So, so this is.
Let me share.
Yeah.
Hold on.
Yeah.
There it is.
Yeah. So can change in a billionths of a second.
Wow.
I mean, this could make computing really.
And that's truly magnetic. So there's no moving parts that will damage each other, basically.
Right. Yeah. There's.
Wow.
Yeah. Now, will the changing charges disrupt these molecules eventually? Maybe. But they already said that its lifespan is, what the heck did they say up here? 100 billion cycles.
That's quite a few.
Yes. Yes. Now the question is, and they don't really answer this in here, is it state persistent? Like if you turn off the power, will it stay where it is? If it is, then they've just created hard drives essentially that are faster than our current RAM.
Okay. Well, that's one of the things that it's called bubble memory, which was a magnetic thing, and it would keep its state. So.
Right. Yeah. Well,
I could totally see that being
any solid state drives.
Yeah,
any solid state drives. Yeah. So it all depends on if this change.
What? Oh, he's talking about Jacqueline's picture.
Yeah. Yeah.
Oh, Daniel's here. Looks like it wouldn't generate much heat either, which is a big limitation for nanoscale machinery. Good point.
Yeah. The question is, how much heat does it take? Do you generate moving it? For the equipment to move it. I mean, and how they
there's
don't.
There's no like physical contact.
Right.
So.
But you have to create the magnetic fields, which takes power. So.
Right.
And here's the thing: what do they have to do this? I mean, do they have to have a room-sized machine just to move this one molecule? If so, we might be a ways off from using this in a
Well,
computer.
computers used to fit in a room too.
Right.
So,
But so,
not anymore.
a room-sized bit, is, not, is kind of going a little bit backward, but it is a new avenue. And if they can get it, if they can get it so that so the total size is small enough, then hey, it'd be essentially a solid state device that can switch memory. Now it'll either just be RAM, or it could be RAM or hard drive, as we call it. In fact, if it is persistent, then it would basically, aside from all of our operating systems assume RAM and hard drive, it would alleviate the need for the distinction.
Oh.
Imagine a computer that processes directly on the hard drive. We'd be going back 30 years, 40 years, because there didn't used to be RAM. It used to go right on the drive.
All right. I don't think I knew that.
Yeah.
That looks like a fascinating article. I'd love to read that.
Yeah. Here, let me.
Oh, get a share. Good.
Yeah.
Cool. All right. So Jeff will put that into the chat. Should be a clickable link.
Yep.
So you can go ahead and check it out.
Yep. And it is Live Science. I don't really know this source that well, but I'm going to be checking them out later as
looks like that
source.
link broke in YouTube. So
YouTube.
you just
you'll have to copy paste them together. Yeah.
Splice those two together. Came out as 2 comments on YouTube.
Yeah. Now here's something. This was just another article in here. It's just a video on.
It's like a robot.
Yes, and
wow.
Yeah, there's no human operator controlling it.
It's still tethered. So what's that doing?
So that they don't break it if it falls.
Okay. So it's strictly safety rigging. Okay.
Yeah, but you notice there's no power to that. That's just a strap.
So what we've got is a neural network, it looks like, for this thing.
Yeah, that it's gotten that good at navigating. That's
pretty cool.
Yeah, because they've given it, here, go here, and don't tell it how to do it.
Do they actually tell you which? I remember seeing an actual demonstration of a robot at Case Western Reserve University when I lived in Cleveland way long ago, and they said it had the neural network of a cockroach, and it moved like a cockroach too. This one doesn't move quite the same.
No,
they don't tell you. Okay.
No, basically, I've seen as much as anyone else has seen right now.
Okay.
I could probably follow it, but that wasn't. I just saw this video today, as because they slotted it in.
Got it. Okay.
Okay. Another thing about integrated circuits is molybdenum, I think MO, and sulfur.
Yeah, I was wondering what the MOS was.
Yeah. And this is a transistor on a 200 millimeter wafer. Again, another type of silicon transistor.
Okay.
It's a transistor. So.
All right. They actually had the diagram of the layers. Yeah, there it is. Oops. Yep, right there. TFT channel.
Yep.
So all those different layers are, they call it doping. So
right, yeah.
It could be silicon with a little bit of boron or a little bit of this.
That's what makes a transistor, is that it's a resistor until you send electricity down a different path, then it becomes a conductor. So that's what switches on.
We call it a logic gate. So it can turn on because you put power to it.
Yeah.
And it'll open.
So, I mean, that's just interesting to me.
MOSFETs.
I figure if you guys are interested, look up here, MOS transistors.
Yep, MOS transistors. Sound like there'll be a lot of cool stuff on that. Is that the Pepsi logo?
No, actually.
I'm just looking at it on my teeny tiny little screen on my computer.
Oh yeah, it does. When it's smaller like that, it does look like
interesting?
the Pepsi logo. Okay. This
random, I know.
Yeah. Simulation, again, it's a simulation, so but gaining a deeper understanding on an atomic level why perovskites are such a good material for converting sunlight to electricity.
What is perovskite? However you say that.
Perovskites, yeah. I think I've mentioned them in a previous news roundup, and look them up. It's something that would make very efficient, much more efficient solar panels. Like instead of topping out at 25% efficiency, topping out at 35%.
Okay.
Which, not huge.
That's a big leap, though.
But it's a big leap. The trouble is that the material degrades so fast. So it actually gets broken down too fast. So it doesn't last even as long as regular silicon ones, which do break down over time.
Okay.
So they're working on ways of, and the simulation is on ways of mixing it with other things so that you keep the properties, but so this is just,
so it won't break down as fast. Okay.
I'm into solar power, and my justification for showing it here is that if we go in space, we're going to want solar power.
Oh yeah.
So at least
near the sun.
Yeah, at least up till Mars.
Okay.
You hit the asteroid belt
boundary.
You hit the asteroid belt, and solar power becomes less useful.
So nukes, got it.
Yeah.
Okay.
And a super black wood.
Okay.
99% of the light, and it gets none of the blackness of it from any kind of pigment. It's not pigment that does it. It's simply the shape of, and what happened was they ended up burning the end of a piece of a very specific type of wood.
Okay.
North American basswood.
Okay.
And
so it's European limewood too.
Yeah.
Nixlon, is that what they're calling it?
Yeah. Oh, it can also be made by European limewood.
Right.
And that's what they're calling it. I have no idea why they're calling it that, but can absorb more than 99% of the light that strikes it. Black paint, which absorbs 97.5% of the light.
Okay, so it sounds like it gets into the nooks and crannies if it's a burnt thing.
Right, yeah. Yeah,
Okay.
and it's just basically changed the shape of it, and it gets all of its light absorbing, by getting the light in, but not letting it back out again.
And I understand that because once upon a time when we were doing telescopes back in Ohio, they would line the interior of the tube with corncob particles and paint them black because, of course, even in a smooth black thing, the light's going to bounce around some. But this way, the light would get captured by all those bumps and crannies.
Yeah. And they are talking about, they did mention about using this in telescopes and other optical instruments.
Okay. Interesting. It's weird how certain experiences kind of come back to, maybe it's a little bit like that.
Right. Now, and this is a website called Interesting Engineering, which
it is.
It intrigued me because a few of the things that I have going here are from the Interesting Engineering.
Cool.
So I went to the site, and they've got an awful lot of really neat stuff there. So I'm going to just show.
Well, there's a rabbit hole for you.
Yep. And it's a much shorter link than that go into that one article.
So probably won't break. Nope, it didn't break. Good.
So
that one's whole in YouTube.
Yeah. So, and you can, like space, you can click on space, and it gives you the space stuff.
That says science at the top, though.
Yeah. Okay. I guess they suck.
Not perfect.
Yeah.
Okay.
But hey.
Yes.
So, but science is still on the way there.
Guess if you're naturally curious, it almost doesn't matter because you're like, that looks interesting.
Yeah.
For practically everything.
Well, fossils of I just saw this.
Right.
Of a 210 million year old lungfish that
caught my attention
dinosaurs.
too.
Yep. So, okay. There we go.
Have fun.
Yeah. Okay. Model suggests subluminal warp drives may be possible.
Okay.
Basically taking the place of impulse engines.
Oh, Cliff has a comment. I learned all about transistors and resistors when I was about 5 years old.
Yeah.
Very cool.
Yep. Yeah. So So they basically have been playing with, again, computer simulations.
Okay.
Basically, we don't have enough energy to make a faster than light warp bubble. I mean, although, okay, I read an article, I lost it before I could even think about doing this show, but I read an article where they actually got it down from the energy of full conversion of the full universe to energy of full conversion of Jupiter.
Okay.
To do faster than light warp.
That's a pretty good leap.
Yeah. And they think that they might be able to get it down to the energy, the full conversion, like as in matter, antimatter, of something like the Voyager probe.
Ah, okay.
So, but
I'm waiting for kitchen scraps.
That's theoretical. Well, that was fusion anyway. That's Mr. Fusion.
Oh, okay.
But
reference to Back to the Future.
Right. Yeah.
By Jupiter.
Yeah.
Okay.
Yeah. You know, basically, if you can full convert Jupiter, you don't have to worry about warp drive, I think. Because you've got some.
You got better tech.
Yeah, you've got better tech than that.
Okay.
But this, you could possibly use this for just moving without throwing mass out the back.
Oh.
You know, so it's a reactionless drive.
Okay.
Which is why I called it impulse engines, because that's what impulse engines are in Star Trek.
Like on Star Trek. Okay.
Yeah. So, again, this is more possible than FTL warp.
Okay.
Doable? Possibly. I mean, now this would, you know, even if we don't manage to make FTL, if we had this, having like 10 years to get to Alpha Proxima.
Oh, wow.
You know, that'd be pretty darn nifty. So, hey, and this was from my good friend.
I think you meant Proxima Centauri.
Yeah.
Okay.
What did I do say?
Alpha Proxima. I don't know where that is.
And Alpha Centauri with Proxima Centauri just mixed up.
Okay.
Just stick them in my brain, mix it a little bit, and see what comes out.
Got it.
Okay. This is my good friend, phys.org.
Ah, yes.
I love this site.
Oh, we've got someone new. I don't know what that means. Okay. Red Angel, welcome. And astronaut Butch and Sonny Williams. Oh, okay. Daniel goes, I bet when they announce reactionless drive, the audience will be silent.
Yeah.
Ha 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 ha.
Yeah.
I think that was a joke.
They'll have no reaction.
And I think I got it.
Yeah. So, again, another rabbit hole for you guys. And just in case I haven't inflicted this on some of you, here you go.
Undoubtedly you have.
Yeah.
Why not? It looks like a good place.
And it's
a short web. phys.org.
Yeah.
Phys.org.
Okay.
It's good.
Oops, what the hell? Oh, that's because I'm on the wrong
different
browser.
window.
Different browser. Yeah. Okay. This is kind of amusing.
Oh yeah, you may have heard about this one. It was all over the place for a while.
Yeah. Planet Mercury covered in a layer of diamonds that is 9 miles thick. Yeah. And DeBurge is now calling them conflict diamonds.
Well, it would be a conflict because as soon as they got here, diamonds would be just rocks.
Which is kind of what they are.
This is kind of what they are.
I mean,
well, they have some qualities that are admirable.
Yeah, useful.
They're pretty. So Cliff says, you see, my dad brought home a full set of Encyclopedia Britannica, 27 volumes.
Yep.
And read to, did he read it to you?
Yeah.
Because it sort of stops there.
Yeah.
Nice. Well, thank you, Dad.
Yeah. I used to read we had neighbors who had the Encyclopedia Britannica. And I used to read it. And I also used to read it at the school library.
We got encyclopedias, but they weren't Britannicas.
Yeah.
They were cool. My friend's material.
Yeah. So this is just kind of neat with Mercury. Now, it's hard to get there. Hard to get them back.
But it's so interesting the things we find out about.
Yeah.
You know, all the things we've kind of known about, and then, oh look, there's such new aspect to it. Very cool.
Yeah. I mean, one of the things is that there's an awful lot of carbon in Mercury. And now they figured out how it how it's in there,
Okay.
and just I think
Crystal and diamond shape. Okay.
heating and cooling over time simulates very slow cooling, which is what grows crystals. So
Cliff said he read those, not fiction.
yeah.
Janie goes, I love looking up stuff in encyclopedias. More fun than Google spirals. Spirals?
You know,
That's a new one on me.
Yeah. So, rabbit hole. Google rabbit hole.
Yes. Okay.
Okay.
Got it.
So, yeah, just, it's space related. It's like, ooh, diamonds. But can you scratch glass with mercury? They're actually
the
below
glass pretty close to it.
Yeah, and you'd have to dig down a bit too, because they're under some layers of rock.
Yes. Well, they get bombarded by
Let's see, somewhere
different things in the solar system. So
no picture. I thought they had a picture of.
That's a neat picture. Though.
Yeah, this is. I don't know if it's a true color or a false color picture of Mercury. Certainly better than the gray rock that everyone thinks about.
I just think it's cool looking.
I hope this is what it looks like.
That's
but I
the fun thing about what we do is we've got a lot of really cool images like this.
Yep. And
that one.
Here we go. This is, we talked about black holes in the announcement for the show. They've figured out one of the things that they're having problems with is that theoretically, as black holes get close enough together, the Hawking radiation from them pushes them apart. Oh yeah, go ahead.
So thanks for coming back. Red Angel, I was reading to a lot of space exploration books.
Yeah. Oh yeah.
Cool.
I think a lot of us on this channel were, but so.
Yeah, I like to read fiction too.
Right.
It's very mind expanding.
Yeah.
Personally.
But, Red Angel, if you can ever find it, George O. Smith's Venus Equilateral collection.
Yes.
The complete Venus Equilateral. These were written long before Star Trek, long before any of that stuff. And I swear Star Trek stole stuff out of that series of short stories.
That author name doesn't quite sound right to me.
George O. Smith.
George O. Smith?
You're thinking of
Corey's.
Yeah.
It's a pen name.
Lee Corey is someone else. Yeah. George O. Smith was a contemporary of Arthur C. Clarke. Whereas Arthur C. Clarke was a physicist, George O. Smith was an engineer. Arthur C. Clarke.
And you could tell in the book.
Yes. Oh, you can tell in the book that he's an engineer because it's about engineers.
It's really good.
Yeah. And Arthur C. Clarke wrote a story before we had radar about radar being fitting in 2 trucks in order to find, to see missiles in airplanes. You basically link the 2 trucks together for the processing for the radar. George O. Smith had them built into artillery shells for aiming, for guiding in. So this was, was the way he'd create a tech, have the tech cause problems, then figure out how to solve those problems. Like replicators. He created replicators. And now what was the problem with replicators? They wipe out your economy.
Yeah, it will definitely change things.
So he had them wipe out his economy. Then he figured out how to have an economy with replicators. That was, black holes, theoretically, as far as everything we know, can't actually make contact with each other. Because as they get closer and closer together, there's a pressure that pushes them apart. Now, we know from gravity waves that they do make contact.
Yeah, in fact, that was that little whoop.
Yep. So,
So
our physics doesn't match our observation. So they basically figured out how they get, from, I think it's like 12 miles away from each other, which is theoretically as close as they can get in order to basically make contact. So that's.
Yeah, because didn't they show them as whirling around each other and then whoop, they suddenly were one instead of 2.
Yeah.
They
Now,
got married.
the other thing that makes it weird for black holes hitting each other is that as you get closer to the black hole, gravity is higher, which means acceleration is higher, which means time slows down more and more. So theoretically, you don't ever make contact with it. So how do black holes hit each other? Yeah. So how do black holes hit each other? So they basically explain that here as a way that it might happen. So scientists created a black hole in a lab experiment. Now, this one's clickbaity because they simulate a black hole. More to the point, they simulate the event horizon of a black hole in a lab. So, and basically, black holes of a certain, they made it glow. Now, does this really happen? Don't know. It happens in the simulation of a simulated event horizon, but does it happen with a real event horizon? Again, yeah.
It wasn't a huge deal, gravity waves, and yes, it was. That was the LiDAR, right? LiDAR.
Yeah.
Detected it, and
yeah. So
it was a lot of. I think we talked a lot about that because of noise. They had to be careful of noise, but once they figured out that it wasn't, all these things were noise, but this other thing was nope. That was.
Yeah. So, yeah.
That was a detection.
Whenever observation does not match theory, then then a whole bunch of
to change your theory.
Well, then a whole bunch of PhD students now have their papers to write.
Okay.
As they try to figure out, the first set is, why doesn't it match theory? Then they start working on a better theory. But yeah, that employs a lot of physicists.
Okay. What you got next?
Okay, a couple articles on heavy elements. And this is transuranic elements, the ones that are past. They're so unstable that you don't see them naturally because none of them have survived.
Right.
But we create them in a lab.
And typically they last nanoseconds or something.
Right. Yeah.
Well, I think it can vary. It can vary.
Yeah. Some have half-lives of an entire second, but who cares? So,
it's the same one.
Right. Yeah. So, they discovered promethium in 1945. They only just learned what it actually does. And this is in Popular Mechanics, and I won't show that one. For one thing, it's a paywall. So if you want to pay them money, you can read their articles. But here's an article out.
Yeah, costed a lot, but provided theories that are not proof.
Yeah. But so this article is the fact that they've been able to create enough of this promethium, which is, I think, 112, somewhere in there. They've created enough of it to actually test its chemical properties.
Oh.
Yeah, because if you've only got a couple of atoms of it, it's hard to really tell what its chemical properties are. So they created enough of it at once that they could test its properties before it broke down. So
they say what the
let's see what it's like. There's a Nature article on it.
Oh, proves the theory.
Yeah,
that's what you're.
Yeah.
Okay. Thanks, Cliff.
So, yeah. So, yeah, they do talk about. Here's the reason why they're looking at interesting properties on it, because as the atoms get heavier, the electron shells get it closer to the atom, to the nucleus.
Do they? Interesting.
So that changes their chemical properties. Because to pull an electron away from it is a little bit harder because it's closer to the nucleus.
Okay.
And it's heavier, and so they don't move around as much. So,
Mhm.
so getting it, figuring out the properties are interesting. I mean, for stuff like this, it goes away so fast that it's almost of the doesn't matter. But as the next article talks about, they're working on.
Wait.
Okay.
We got a comment. Red Angel comes back with the different ways of black holes.
Yeah, just different things that we were learning, I guess.
Okay.
They made a new way to make element 116, which is something that we've made before, but they've been able to make it easier.
Okay.
Which there are 118 known elements that we've actually created.
Well, a lot of them are found.
Right. But the method that they created, for this means that they might be able to make element 120 with the same method.
Oh.
Just because the number of protons and neutrons and stuff, they can use the same method to make that. There are sweet spots for making different things. So,
okay.
So they might not be able to make 119 using this method, but 120 they might. The neat thing about 120 is that 120 is possibly stable.
Okay.
It's getting on the edge of what they think is a stable nucleus.
Now, is it stable because it fills its shell with electrons?
No, it's because the neutrons, the protons and neutrons don't hold each other together well enough that they're not likely to fission.
Okay.
Basically, because like uranium, it splits just because the pressure is in, basically, I don't know enough of I used to know, but I don't remember enough of it to know. But there's
any chemists out there,
as they get bigger and bigger, they get more likely to split.
Okay. I thought it had to do with like
pressures.
So there are divisions of shells in electrons.
Oh, those are electrons that have nothing to do with this.
Yeah, I thought it was because the shell was full.
No.
And it couldn't.
That's chemical properties.
Okay. All right.
Yeah. Fission is just the nucleus itself gets too big for the forces holding it together. And it just goes kablooey. And if you hit it with a neutron, it's more likely to go kablooey. It's kind of like it's unstable. Then you just whacked it with a neutron and, it's kind of like nitroglycerin. Okay. It's just sitting there waiting to go off. But theoretically, that they get heavy enough after a certain point that they become stable again. Again, it's only theoretical, so they haven't been able to test it. They haven't been able to create something. Yeah. And they only created a little bit of this in I think it was like a couple months. And they say that using the same method with slightly
about expensive.
Yeah. Using the same method, it'll only take 10 times that long to create some element 120. They've already got a name for it, by the way, because they've theorized the element, but no one's actually made it.
Yeah, it reminds me of the book I finished reading by Stephen Eckroad. He was one of our guests, and he wrote 4 books. I bought them all, and I'm on number 4. It was Copernicum, and the whole idea was that it was a naturally occurring stable element, which had only been made in the lab before. So it's very interesting series.
Yeah. So and because it has different chemical properties, science fiction writers use it as well, we can do anything with this because we don't know.
Yeah, but he actually knows.
He actually knows.
That's what I really like about a scientist who becomes a science fiction author, because they do know things and they extrapolate from a place of understanding.
Yeah.
So,
well, of course, I read a story written in the 70s that dealt with the same sort of thing, and we knew so little about it that it was wide open. So this is.
Oh wait, I'm sharing again, right?
Yeah. Basically, it uses titanium 50 instead of a calcium atom to do this. But they hit plutonium 244 with titanium 50. It fuses into this livermorium, which is 116. and it gives off some neutrons and becomes a different version of livermorium, and it's somewhat stable but not very.
Because those numbers are not.
Yeah,
they're different on the back of those.
Right. Protons and neutrons.
294 versus 290.
Right.
How is that element 116?
Because 116 protons.
Okay.
The atomic number of something is how many protons and neutrons there are. So like helium-3 is 2 protons and 1 neutron. No, yeah. Helium-2, which is somewhat rare, is just 2 protons, no neutrons.
So Cliff helps us out here. Shells are the different amounts of electrons. The further out from the nucleus, the more electrons are in a shell. So there are layers of electrons. Yep.
Yep.
Well, it's different for different layers. It's
right. Well,
and I don't know that it's strictly more.
And it's based on energy potential, not
right.
They don't actually orbit. They just have.
It's a field.
Yeah. They just zip around randomly. We actually talked about it in a previous episode. The closer they get to the nucleus, the faster they go. So even though it travels past or through the nucleus, you're less likely to find it there. So there's this band around it that it's more likely to be, simply because it's slow enough and it's more likely to be there. Because the further out you get, the less likely it's to be there. So there's this sweet spot, and there's different energy levels. So once the lowest energy level is full, then the next lowest starts filling up, and that's why we think of them as shells, because
it's a kind of a convenient visualization.
Yeah, they operate as shells, but
it's truly a field of probability.
Right, and they're just there somewhere
where it might be.
Right. Yeah. In fact,
there.
Oh, we talked about it in white dwarfs.
Okay.
Because that's what happens, is that they get crunched together close enough that it collapses. Or neutron stars. Neutron stars, they collapse, and then white dwarfs.
Okay.
Oh, white dwarfs, then neutron stars. I'm just getting mixed up. So
it's okay.
So here's this 116 here. This is our chart as we know it right now, of
periodic chart of elements.
Yep, of everything we've been able to create.
Oh, he says also for chemical bonds.
Yeah.
Yes, yep. Chemical bonds, right.
Yep. Yeah, because
I was thinking that, and you said it.
Yeah. Because the ones with the that are, that have the lowest bond to the atom are the ones that are most likely to go away. So it's likely to trade off the ones in the quote outer shell. That's just basically because the inner energy levels are less likely to be affected by chemical interactions. So
okay.
So yeah. So
hang on, I'm sharing again.
Yeah.
There you go.
Oh, it only took them 22 days of operation to at the cyclotron to make this. So
it'll take less than a year to make the next one.
Oh, they made 2 atoms of 116 in 22 days.
Wow.
So it'll only take 10 times as long to make what element.
There you go, Cliff. Calculate the price of that.
Yeah. Yeah.
How much per atom?
Yeah, because considering how much juice they're throwing through an 18-inch cyclotron.
It says 88.
Or 88. Sorry, 88. Yeah.
Oh, originally wanted to be a chemical engineer at 8 years old.
Yeah. So
what you do is very cool too.
Yeah. So here's where they take titanium-50, get californium 249, which is fairly unstable. So you have to get it when you can. And it makes element 120, which doesn't have a name yet because no one's actually made any.
Oh, Daniel is running again for District 5 City Council. Well, thanks for sharing your exciting news, Daniel.
Yeah. So, just, let's see, is there, yeah. It just, it's a feat of engineering at this point. We might learn something from it. If it is,
undoubtedly we'll learn something from it.
Yeah.
And of course we'll create more questions. Anytime we go for answers, we generate more questions.
Yeah. And if they can make it stable, then they need to figure out if it has useful properties.
Hmm.
You know.
Yeah.
Um,
And that could come anytime. I mean, the laser was created before they had a use for it, but
yeah.
clearly it's very useful.
Yep. Construction of U.S.'s first fourth-generation nuclear reactor. Just putting this on here because we're going to need nukes. You know, hopefully fusion, which is why I talked about that first. But fission works too. Yeah.
Didn't you have uranium in it? Because man, I had started to build my chemistry set, and at 13 it was huge.
Yeah.
Yeah, we just saw something about the uranium and chemistry sets.
Well,
they had to be removed.
Well, yeah. Well, this was 1950s, and they were selling it for $60 then.
Yeah.
That's like $50 then. It was like $600, so it didn't sell well.
Ah, nice.
But
J.D. Becker.
So
best wishes to Daniel.
Oh yeah. So this reactor is actually a safer reactor. It doesn't use water that can boil off. It uses molten fluoride salt.
Okay.
And the fuel in it is stored in a ceramic that can take more heat than it can take. So you won't have fuel rods melting into each other.
Okay.
You know, so they basically designed it to be.
So you've got the rod encased in a ceramic, and the ceramic won't fuse together between the rods.
Yeah, because it won't melt.
It won't melt. Okay.
Yeah.
That sounds cool.
So they made it passively safe. I mean, worst thing that happens is that it sits there and glows for a while.
Okay.
But then, you know, they can make it stop being hot just by throwing some, you know, damper rods in it. But if it, even if you shut off all power, stop everything, it is passively safe. Even if the molten salt drains off somehow, these things won't melt. So they won't spread the radioactivity all over the place. You know, so it's a much safer way of doing it.
Yeah,
so
sounds good. I think one of the first ones was, you know, if the power cut off, they would just drop into the water, right, to cool.
Right.
But if it has to be raised or something, then it's a problem because
the first ones that we had,
the other ones are gravity.
Yeah, the first ones that we had damper rods that were shoved in from the side. That was the first pile that we had, simply because it was easier to get to the side of it than top it or down.
Oh my God. A bottle of mercury.
Yeah, you can buy it then. Yeah, I know.
Not anymore.
Nope.
I hope you didn't get any on you.
No, it's breathing the fumes that gets you.
Yeah, I've heard about getting it on your skin too.
Yeah, but
no bueno.
Yeah, what caused Fukushima's problem is that their damper rods came up from the bottom. So if they lost power, they couldn't get the damper rods up.
Right.
Whereas
ours were all gravity, so
which makes it
falling.
Yeah, which means that it would fail unsafe. Ours go down, and they made it so that the top part of it was super thin and had a lower melting temperature than everything else.
Okay.
So if the plant gets too hot, the top part of the rod will melt and drop the rod in. You know, so.
Yeah, good.
So that was.
Anything.
Yeah. So that was an actively safe.
I don't know about that, Cliff.
Yeah.
Especially now.
Yeah. But,
don't be like Sheldon.
Yeah.
At 9, he ordered uranium or something.
Yeah.
And who came? Somebody from the federal government came
to
talk to him.
Yep. But well, in fact, someone else tried something very similar, and that they bought a whole bunch of smoke detectors. They bought thousands and thousands of smoke detectors.
Is that the one on BMA's? Oh, we saw one that was like.
No, not
those kids.
Yeah. But they bought thousands of smoke detectors in order to pull the rare earth out of it. That was a fissionable material.
Google the radioactive Boy Scout.
Yeah.
Okay. Interesting.
Yeah. So having a fusion plant or fission plant that feels, that's passively stable.
Feels safe, basically.
Yeah. So that's good. You want something that won't blow up on you or melt you or stuff like that
It's like
when you're in space.
most elevators now. If they lose power, they have magnetic brakes. So once they fall, the magnetic brakes will activate and you will slow down.
Yeah, basically it takes power to deactivate the brakes. So as soon as the power goes off, the brakes activate. Yeah, Americarium.
Oh,
Americium. Yeah, in
Americium. In smoke detectors.
Yeah. And
cool.
so
Thanks, Cliff.
Yeah, in fact, that's how they're going to be making that element 120.
Oh, okay.
That's
Am I sharing again?
Oh no, it isn't. They're using Californium. Oh,
Californium.
Yeah, but
similar.
Okay.
Oh, Don says lots of interesting articles tonight. Thanks for joining us, Don.
Yep.
Glad you're here.
Yep. And again, interesting engineering. So Samsung makes EV battery breakthrough 600-mile charge in 9 minutes with a 20-year lifespan.
That's a big deal.
Yeah.
That's a big deal. Good.
And they made them, and they're safer than lithium batteries because they're solid state. There's no liquid in them.
There's liquid in lithium batteries?
Yes.
Oh, I didn't know that. For
Um,
some reason I thought lithium was a solid.
It is, but then there's a liquid in between the two.
So it's more like a capacitor?
Yeah.
Oh, interesting.
Well, essentially a capacitor is a battery in some ways.
Yes.
The difference between
some batteries are capacitors.
And
that's part of why they charge so fast.
Well, and the difference between them is getting smaller and smaller.
Yes.
Between because one is fast discharge, the other one is long life. That was the capacitor can discharge fast, battery can discharge continuously.
Always trade-offs in engineering.
Right. And capacitors generally lose charge faster than a battery does.
Okay.
Which is why you only have to unplug your computer for about 10 to 30 seconds before all of the capacitors discharge. But so by making a solid state battery, one, it has a longer useful life.
Am I sharing again?
Sure. It has a longer useful life, and apparently it charges faster. So
that sounds extremely useful.
And it's not as heavy.
That sounds even more useful.
Yeah. Yeah, you take a good chunk of the weight off of, like, say, a Tesla, and well,
the thing about that is they're not going to flip over very easily, right?
Right. Yeah.
We got a comment. Cliff says, sit one on same unexposed photo paper and then process, make some neat pictures. I think he's talking about the Americium.
Yeah, because the neutrons that it gives off whack the photo paper and produce image on it.
Yeah.
So
that was the first way they figured out X-rays.
Yeah. It's also how essentially the badges work, the radiation badges, to see how much of a dose you've got. Same principle.
Got it.
The redder it gets, the more dead you are.
Yay.
So this is a nifty way of doing it. Another article on another way of doing potassium ion battery.
I think I've heard of this one.
Basically replaces lithium. Now, here's the good thing about it. Potassium's easier to get.
Okay.
It has essentially the same properties as a lithium battery.
So it's the same row in column.
Kind of, yeah. It works essentially the same way. I don't know its chemical properties as much, but it works the same method as a lithium battery. And
so I don't know what real stuff is, Cliff.
Yeah. But so they say it's as good as a lithium battery, but it's cheaper to make because potassium's easier to get.
Got it. Okay.
Is it as prone to blowing up? Well, here's the thing. They have this video of lithium batteries catching fire and blowing up in there. But they never actually say in the article that it has less likely to catch on fire. So Essentially,
so it does or it doesn't. It's less or more. We don't know yet.
Yeah, but essentially, it's the same weight. It's the same. Has all the same properties of lithium, except that it's cheaper to make, and you don't have to dig through rare earths to get it. I mean, the one thing that everywhere that they find lithium, they also find stuff that's pretty hazardous around it. So, and that's why, even though we have huge lithium reserves, we're not allowed to mine it because it might cause problems. So
environmentally,
we let poor people in other countries mine it so that they can get the health issues, not us. But if we can make these same batteries out of potassium, hey, I mean, that's easy.
Got it.
Heck, kill people, grind up their bones, and you get a bunch of potassium.
Excuse me? Oh, here we go. Cliff says they got real pieces of americium and strontium.
Yep.
Well, the high school was probably authorized.
Yeah.
Of course, it's different now too.
Had a friend who got a new high school teacher.
Okay.
A high school chemistry teacher decided to get rid of these bricks of silver metal. God. And just tossed them into the waste bin outside.
Sodium?
Yeah, unfortunately, it had been raining the past days, so there was
Sodium.
water. Yes.
Boom.
He said it made a smoke ring.
Okay.
Tossing it into a barrel, a 50-gallon drum barrel, which is what a lot of schools used for their trash cans, and bowed out the sides of the barrel. But since it wasn't completely enclosed, it didn't blow up the barrel. It just, it just poofed it, and everything shot up the front top. Okay, so fusion.
I'm sharing, right?
Yes.
Okay.
Fusion. The holy grail of space travel is getting a fusion reactor going. Yeah. They made a way of making the plasma stream 10 times denser.
Okay. Is that magnetic bottle or something? Yeah,
they didn't do it by making the magnetic bottles stronger.
Oh.
Well, they did, but not very much stronger. They did it by making a huge shell of iron or other metal around it. So that the magnetic field used this huge thick shell of metal as a buffer, because the plasma would kind of interact with the magnetic field and wiggle the magnetic field, and that would cause disruptions in the rest of the plasma. So it was always a lot of computer control to keep it stable. But this huge, kind of like the chunk of iron in a transformer, it just acts as a moderator.
Okay.
So just by having this much metal in there and putting the magnetic field in it, it kind of holds onto the magnetic field better, so that the plasma is less likely to wiggle the magnetic field.
Have metal donut will travel.
Yeah. So, again,
that'd be cool in the engineer.
Yeah, not as
in the warp engine.
Yeah. Not as good as for space travel because it's very heavy.
Oh, well.
More metal, more heavy.
Out in space.
Right.
Weights.
Well, more mass that you have to move. But
yeah, it's not that big a deal, though.
Right. Yeah. So
it's stopping it.
So this is another step on getting good fusion.
Got it.
And this other method, whereas this is more of the brute force method, more of this is flexible stellarators.
Say what?
Stellarators.
Stellarators?
Yes, as opposed to tokamaks, which
no
are
idea what either one of them
is. A tokamak is the donut shape.
That's okay.
That's torus, yeah.
Yeah.
A stellarator takes this torus, and even though the plasma is unstable.
Wait. He's gesturing.
The plasma is unstable, but what they do is they twist it. They have it twist. So it's kind of like doing this. So all of its side-to-side movement is taken up in this twist.
We saw that with the Yvonne Brills.
Yeah. So this is what they're doing to make it more stable, and thus taking less power to hold the. Yeah. So they're making it denser and or take less power. So they're making the break even easier.
Nice.
The only trouble is that if you see this image right here.
I guess Cliff went to a bunch of high schools.
Oh, yeah. I only went to 2, and one of them was only for half a year. Then we moved from Michigan back to California. But so it has these really funky, it has the normal magnetic fields,
Is that the stellarator?
Yeah.
Okay.
And it has these helical bands here, which have to be done just right to do this.
Okay, all right.
So,
we've got precision computer work,
right,
so
yeah.
we can do that.
Yeah.
That doesn't seem that hard to me.
Yeah. It's finicky to put together too, because you have to theoretically get the right curve, then you have to put it together just right. And so
get robots to build it.
Yeah.
Or nanometers.
Yeah. It's very finicky. It's very finicky, but theoretically it does a good job. Now, could they combine the two? Maybe. I don't know. I don't know if the thick metal would interfere with this helical set. But in any case, 2 different methods of doing it. This is more finicky but lighter weight than the thick metal casing.
Okay.
So, hey.
Yeah, there's probably some engineering quiescent point.
Yeah. And another this is clickbait, because this isn't really a breakthrough. This is just they've tested what the effect of the neutrons is on the parts of the tokamak reactor. Because neutrons hitting things, because in fusion, that's what happens. It gives off neutrons. But, different sensors and stuff like that can be degraded from it. So they just basically that's what this is. It's just they measured the degradation rate. So at least you'll know how quickly you have to replace things.
Okay.
Let's see other
Sounds
stuff.
kind of useful and interesting.
Yeah, like I said, it was kind of
a lot of tabs up there, buddy.
Yeah, I do, and I think we've been at this for about an hour.
A little while.
Let me just show these and just blow past them. Drought Buster Solar Tech extracts 3 liters of water from thin air daily.
Nice.
That's only 3 liters. That's enough for one person, but it's a fairly big thing. And this is interesting engineering again. Yeah.
I got a picture of it.
Let's see. Oh, that's something else. Here it is. They collect the water onto something, and then they evaporate it off of that, and then they get it off of, they collect the water into something that absorbs water, and then they get it off of there. And it's a 2-step process. They have to switch it, they collect the water, then they get it out of it's kind of like a sponge. They stick the sponge in, then they squeeze the sponge out. But and they got it.
Show the title again if you want to search for that.
Yeah. They got it by
Solar
looking at
Tech,
the way
3 liters of water.
at the way plants absorb water.
Oh.
So.
Yeah. Nature's a very good model.
Spacecraft travels to a metal object orbiting Earth. Basically, the Japanese everyone talks about space junk. The Japanese are actually doing something about it. They picked this as a second stage of something that's just floating out there. And they flew up to it, took shots of it just to prove that they can intercept it. And their next thing is to make something that can grab it and
resources.
Well, they're looking at just slowing it down enough to burn up in the atmosphere. But at least it'll get it out of there, because they said that this thing, if it hits something, it breaks up into enough small pieces that, it'll destroy a lot of stuff in its path.
Yeah. Bad things.
So getting the big things out of there keeps the small things from, so
reduces small things eventually.
Yeah. New evidence for Planet 9, or as I call it, Planet 10, because
Pluto, yeah.
Pluto, yeah. Everyone's looking for Planet 9. I know where it is.
3. Okay, Cliff says 3 LT. You could survive, depending on environment. Oh, 3 liters.
3 liters. Yeah.
Yeah. I mean, if you had to,
Yeah.
you'd be doing better than none.
Yeah.
For sure.
Yeah. So Planet 9, they found, now they still haven't found actually any images of it, just more things of, things clumping together in ways that means that there's gravity.
More circumstantial evidence.
Yeah, more circumstantial. In fact, that's exactly what they say.
I see.
Okay. Now, of course, anything that they find is likely to not have cleared its orbit. Therefore, it's not going to be any more of a planet than they said that Pluto is, because their thing is that Pluto hasn't cleared its orbit. Well, if this hasn't cleared its orbit, then it's not a planet, so neither. They can't. If I can't have my planet, they can't have theirs.
Pluto is a planet.
Ice Zero. If you remember the Vonnegut story, Ice 9, where they create an ice that causes water around it to freeze, and so it eventually caused Earth to become an ice ball.
I do remember that now.
This is Ice Zero. It's just they found the transition of water to ice, yes. how the molecules line up just before it becomes ice. So it can lead to a number of different things of chemical processes of things freezing and stuff, including, and they talked about cryogenics. If they can figure this out, they might be able to keep ice from crystallizing and expanding.
Okay, now I understand, because if it expands in your
cells
they
the
burst.
Cells go pop. Yeah. So
cryo is hard because your cells can be damaged.
A method to straighten curved space-time.
Okay.
Again, this is all theory and stuff. So this just interests me, and it's phys.org,
Yeah, okay, good.
One of my friends there, right there, is phys.org. Muon accelerators. You thought electrons, protons, and neutrons being accelerated is fun. They're accelerating muons. Now, they can't do a lot of it because muons tend to be very wiggly and get out of the beam. So it's hard to have a beam of them.
That could be useful.
They found a way of making them cooler, which I think just means wigglier, because as things go faster, they're essentially hotter, but if it vibrates less, it's less likely to get out of the beam.
So less wiggly.
Yeah.
Okay.
But they're looking at making this in the Large Hadron Collider. So neat. They could find stuff. Standard model. Interesting engineering again. This is part 2. Deep dive into modern physics. If you want a good article on that, look it up in
Interesting
Interesting
Engineering. Yeah, we've talked about standard model before.
Yeah. So that's just, like I said, I'm not going to get into it. Just they have a good article on it, and the part 1 I haven't seen yet, but probably good too. Discovery shed lights on the origin of matter in the early universe. Basically when the early universe 250,000 times hotter than the core of the sun, which was too hot for protons and neutrons. Essentially, they're saying that it didn't form as early as we thought. It was very, very late, in that it's like, let's see, 0.00001 seconds after the Big Bang.
So long.
Yeah. But phys.org. They found dark oxygen in the ocean. The only thing that this really does for us is it provides a source of oxygen that does not require a photosynthesis. Because it's a chemical process from metals in the bottom of the ocean. They absorb oxygen and give it off. So they keep a steady level of oxygen around them. And so, yay, I don't know. Interesting. I thought maybe they found like like a different isotope of oxygen or something like that. But no,
Oh,
nope. You
I
know,
saw something Fraser Cain did on his show about this too.
yeah,
I didn't watch the show, but I saw that.
yeah. And so actually, look at Fraser Cain's because he did an entire show out of it. He obviously did more research on it. Might have found something interesting there. So that's all I have.
Oh, that's all you have? Okay.
Yep. Yeah,
So
only that.
Only that. Well, that's quite a lot and very good stuff. So maybe in another 6 months, we'll do another roundup. Who knows? So some stellar events this week, and we're talking about August 9th through August 16th. We've got a meteor shower this week. It's the Perseus meteor shower, and it's typically, and I'll show you my thing here. It's typically August 12th or 13th. However,
Well, that's when it peaks. It's been It's been going. In fact, when we were out, when did we head out?
I think we saw.
I saw two. You saw one.
I think I saw something like a very bright. I would call it almost a boloid. It was.
Yeah.
But it was really short. I was like, oh, is it a firework? No, it seemed more like a boloid.
Yeah. I saw two streaks heading generally northward from about 45 degrees up, then heading northward.
Yeah, that seems likely. So yeah, on my chart it says that they peak between the 12th and 13th. Someone told me that it was the 10th, so I'm thinking, well, maybe they're saying that because Saturday night, the 10th is Saturday night. It's a good night for people to go out and look. But I'm going to talk about it. I'll talk about it right now because it could be this weekend. It could be a little bit later on. The date range is July 17th through August 26th. So there could be at any time in that period, and they would be attributed to the Perseids. But that peak is around somewhere around now. It's going to be look northeast after midnight, radiates from the Perseus constellation. We have about 50 to 90 per hour, which is pretty good. The source is 109p and Swift Tuttle. August 10th, Spica is 0.7 degrees south of the moon. August 12th is the first quarter moon. August 13th, Antares is 0.1 degrees south of the moon. That sounds like an occultation almost.
Yeah.
August 14th, Mars and Jupiter are in conjunction. On the 15th, the moon runs low. It didn't say low on what. August 16th, we are back to our Friday night show, and I'm going to do something regarding my book because it's been a really long time since I really talked about anything in my book. And, well, more in a minute. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for this coming week? Go ahead.
If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, August 16th. Well, Pam will pick something from her book and talk about science magic, activities that you can do at home.
Yeah, it's actually like something from the book, science magic, and I don't know, something's cooking in my head. We'll see what happens by next Friday. And I have another comment. You know what we forgot to do last week? We did not do the shout out.
Oh, yeah. Oh, yeah. Sorry about that, folks.
I've been seeing some of her stuff. The professor.
Oh.
I saw
Ohio.
Something.
Oh.
What?
No, oh, wait.
Oh, and professor.
Oh, and professor. Oh, okay. I thought he was saying she was from Ohio. Okay, yeah.
Yeah, I don't know where she's from.
Maybe
I just kind of found out about her.
Yeah, we should look up that.
I got one
show.
queued up. I've got one queued up.
Yeah. Okay, yeah, cool.
So, do you want to do a shout out?
Sure.
Thanks, Cliff.
And
Janie. And Dawn.
And
Daniel was here. Yay.
And
oh, and somebody new.
Yeah.
Is she Red Angel?
Red Angel. Yep.
And Scott was here.
Yep. I think that's
Jacqueline. Oh, that's Cliff.
Yep. Yep.
I'm looking.
I think that's it.
Did we get everybody? Scott, Janie. Yeah. Thanks so much for being here. You are our most diligent regular audience. We really appreciate that, and you always make it much better for us too. So,
yep.
Thanks for that. Anything else from you?
Nope.
And we'll watch for your comments ongoing. Oh, I see something already. Is that what that means? Yeah, new comment. Oops, wait. Let's not do that. Yeah, I did enjoy what I've seen already. Yeah. Thanks for that. Yeah, we love recommendations like that. And, and if there's a way to get a hold of them and bring them on the show, that'd be terrific.
Yeah.
Too. So yeah, that'd be really fun.
You notice a number of your recommendations end up making it into into later episodes. So yeah.
Yeah, they do. We really appreciate that. So all right, folks, have a really great week.
Yep.
And we'll see you on Friday.
Good night, folks.
16th.
Yep.
Good night.